Do you hear me? Do you hear me? All right. Can you double check whether you are in this list? Wait. I can see here only a few students. If you are not here, it won't be that easy to write the online test. So the ones they are here in the Discord, if you don't see yourself, check your Neptune message. I sent out a reminder and be here for the next week for writing the test too. Are you talking about the test or the exam? But you know, wait. But we have, I mean, time slots for 11 to 12. It's here. Only one doodled it to be there. I mean, I don't understand your wish. I mean, you can write your test from 10 to 11 or 11 to 12. In both cases, we have time slots. Look, it's here. I mean, I think there won't be. I mean, at first, let's write a test 2, and I want to see how many people need to rewrite any of them. And if there are lots of people, I will create a new online test for test 1 or test 2. But let's wait for the test 2. So at first, write the test 2, and then we can talk about rewriting any of them. I don't know. So I can't move you from this one to that one. Uh, I think uh, if the test, I mean, these time slots were prepared for the option when you can come to the university, because I wanted to take the group into small pieces. But if the test will be online, you will write it during the seminar when you have time. So you don't need to worry about that one. This is only for test if you can come, but it seems to me right now you won't be able to commit. So you can even forget that doodle because right now it's out of the question. If you can come, we can try it, but I think it's not an option. So it seems. All right. In the. I didn't want it. For the second test, you will solve a seesaw example and this pure rolling. What is seesaw example? I will give you this plot or drawing and add, let's say, M1 is 5 kilogram, R1 equal 1.5 meter, M2 equal 6 kilogram. What is R2? That will be one of the questions. It's pretty simple. You should calculate torque 1, torque 2, Alright, so once again, that doodle was for the option when you can come to the university. It seems you can't. So forget the doodle. We will write the test during the last seminar. Go back to example because you will see it in the test. What is R2? This is G1 times R1. This is M1 times G times R1. This is 5 times 10 times 1.5, which is 75 Newton meter. Tau 2 is G2 R2, which is M2 G times R2, which is 6 times 10 times R. Thanks. 2, and for equilibrium means, since this is a tau 1 is a positive, let's say that direction, tau 2 goes in the opposite direction, 75 divided by 60 will be the R2. Alright, so right now it's no time, it's not the right time to talk about rewriting the first test. At first, let's write the test 2. If you registered for the Moodle, you have homework, and if I see your test 2 was pretty nice and you finished all your homework, I won't ask you to come to rewrite the test 1. So let's talk about test 1, when and how to rewrite the test 1 if you all finished the test 2 and your homeworks. Alright, that was the first one. And let's go to the second example. The second example is this pure rolling. That's nice. It's a nice different formula you can calculate with, but how can I say? I know if you write g on the both side of the equation, it doesn't matter. But technically, the torque, or what if I ask, what if the torque on the left and the torque on the right side of the seesaw, if you can solve it? If you can solve it like tau 1 equal, I don't know. For me, it's okay. We have a flat surface, we have a cylinder, and we pull this cylinder with the force F, and it has a mass, it has a radius, and since the mu equal non-zero, let's say 0.5, there must be some uh, friction force. At the very beginning, we don't know whether it's static or kinetic, so let's go through this equation and try to find out whether it's static or kinetic friction, and in this case, please calculate the acceleration and angular acceleration. Oh, by the way, you have to know the force, so let's say it's 100 Newton, the mass of the cylinder is 50 kilogram, the radius is 1 meter, and you've seen mu equals 0.5. I think we did it last time and try to do it now alone. I will give you, let's say, 10 minutes. Try to solve it alone. All right, let's solve it. There are two kind of dynamic equation. One is the translation, which said the sum of the forces had to be equal m times a. And for rotational dynamic equation, sum of the torque has to be equal moments of inertia times angular acceleration. Pure rolling is the same. We have to assume something at the very beginning. Let's assume it's a pure rolling. The pure rolling condition said acceleration equal r times alpha. So what is your result for a, alpha, and what is the t? Write it in the Discord, please. And I will add in the test also, this is a cylinder, so moment of inertia is 1 over 2 mass radius square. What is the result? All right. So since f minus t equal m times a, the sum f is, if this is a positive direction, f minus t. Only the t will rotate since f goes through the f times r equal 1 over 2 m a, oh sorry, m r square times alpha, and a equal alpha times r. That means t will be equal 1 over 2 m a. This 100 Newton will be equal 3 over 2 m a, and a therefore will be this. Yes, so this is 50. Let's say this will be 2 multiplying by 2, it's 4 over 3. That's right. Alpha equal also 4 over 3 since r is 1. But don't forget this is 1 over s square and this is meter per s square. Let's check this condition. It's 1 over 2 times 50 times 4 over 3. That's just, let me double check. Yes, so it's 3 Newton. Can it be a static friction? Static friction means it has to be smaller or equal than mu times the perpendicular force, which is the weight, 0.5, 500 is 250 Newton, so it's okay. Let's answer the question. So in 10 equal t second, the body, if the v equals 0 and the xt equals 0 is 0, it was not that nice, it will be moved like 4 over 6 10 square, which is 400 divided by 6. Yes, that's right. I think that's all. So again, you will get these two examples. Since there is no way to see where you missed anything, you will have to add numbers like here in the Discord. So if you can do it, you no need to worry. If you can't do it, you have to practice enough, because I can't give you any partial result. If the result is okay, you will get the point. If you fail it, you can perhaps try it, but you have to calculate till the end. You have to calculate the right value for this online test. I won't be able to find any error since I won't see how you solve the example. So be correct, try to finish it. That's all. Yes. Yes, where is the body at t equal 1 second? And also you can answer what is the speed at 10 seconds, but it's very simple. It will be about 40 over 3, which is 13.3 meter per second. So once again, yes, the speed is a normal question. I haven't learned how to do that online test. I will go to an expert now and he will help me to create an example like this. So once again, you have to solve it. Otherwise, you won't have test 2. If you don't have test, you can't register for exam. So at least these two examples, try to solve it because it's a must to have a nice test 2. Otherwise, it's hard to finish this semester. Any other questions? Then take care of yourself and let's meet in a week when you will see the online test will be open exactly at 12 in a week. Bye.